Okay, so this is an example of a boost converter. So I have 5 volts that I'm measuring in parallel with this. There's 5 volts across this capacitor right now. So my actual power supply is 5 volts, and there's a diode, so maybe there's a little bit of voltage drop, but not significant, 0.7 or something of that nature. So this sounds about right. But so I got my positive lead there, and I have my ground down here, and my positive for my voltmeter is going here on this lead, and then my negative is here in this lead across that capacitor. So anywho, what this boost converter is doing is I have my power right here, and it's going through, the current's going through this inductor right here. So the inductor has 2 ways it can go. It's connected to this switch right here, this normally open switch, and it's also connected to this diode. And so since this is a normally open switch, right now what's been happening is the current's going through this inductor and through this bias diode, which only allows current in one direction. As it's going through this one direction, it's charging this capacitor. And so if I'm measuring in parallel with that capacitor, say if I had a load and I want to have a higher voltage across this capacitor, and therefore if I have a higher voltage across this capacitor, it can discharge onto my load, which is going to be my voltmeter in this case. But if I want that, I have to find some way to make the voltage across this capacitor more than the input voltage, and the input voltage right now is roughly 5 volts. So that's one path that the current through the inductor takes. The other path is that the current can go through the inductor, and then once I press this switch, the normally open switch closes and it short circuits. So the current just goes right through the inductor all the way to ground. And so what's happening in that case is when we have current going through an inductor, it's causing the inductor to create a magnetic field. So right now there's a magnetic field in this inductor, and the moment that we short circuit it, it changes the magnetic field in the inductor and induces an EMF. And so what that means is you're disrupting the magnetic field and inducing this EMF, and it basically polarizes this inductor into being another voltage source. So instead of just having 5 volts, the amount of energy that's stored in this inductor adds with the input voltage. And this will be kind of more explained in the descriptions I have. So, what should happen as well is if I press this button for long enough and I don't burn this inductor, it should start discharging, because I don't have a voltage source providing voltage to that capacitor anymore. It's all going straight, it's all being shorted. So as you can see, it's kind of discharging and discharging and discharging. But I don't want to do that too much. But as you see, the moment that I took it off, the voltage increased. I can already kind of smell it burning. But as you can see right there, and then it's kind of steady and it's kind of slowly discharging. So if I keep on doing it, keep on pressing the button, what it's doing is it's cycling through where we're short-circuiting it and we're making an EMF, and the EMF adds with the input voltage and thus creates a higher voltage across our capacitor that's discharging onto our voltmeter right now. So that's what a boost converter is.